Today we'll be looking at overlapping right triangles similarity. There's three parts to this video. I will give a quick explanation of what similar triangles are. I will show you why the overlapping right triangles problem has three similar triangles. And I'll actually show you how to solve for an unknown side using proportions. So, what is similar triangles? The key is all sides pairs are proportional and all angles are equal. And when I say all angles, that does not mean each one has to be 60. It means each angle pair needs to be paired up. So 50, 130, that's 180. That's a triangle. If I decide to copy this triangle and paste this triangle, I have the exact same triangle. Okay? Yes, they're similar, but more precisely, they're the same. They are equal. The key is if I shift it smaller or bigger, the angles do not change. Some people think the angles get smaller. No, they're still 50, 130. The sides get smaller. So maybe it's something like this was a 3. This was, let's say, a 5, and let's say this was a 10. And maybe I made this go to 1.5, 2.5, and 5. What that means is this side got cut in half, this side got cut in half, and that side got cut in half. So all of the sides got cut in half, but all the angle pairs stayed the same. So notation that you might see is S, 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 A, A, A. This is saying all of these are equal pairs, and all of these are proportional sides. For similarity to hold, all three side pairs have to be proportional and all three angle pairs have to be equal. So that's why I wrote SSS and AAA. Okay. Now, what's neat, and I will not prove this in this video, is if I tell you that two pairs of angles are equal, everything else pairs up. So if I gave you a triangle, and I will not necessarily draw it to scale, but if this is 50 and let's say this is 40 degrees. What you already know is if you have a 50 and a 40, you know that other side is 90. And what this postulate says is if I make a smaller triangle that also measures 50, 40, and then that means that's 90, the sides will be proportional. So I gave you an A being 50, so that guy was 50. I gave you another A, which was 40. That allowed you to know that the third A was 90. And then because I gave you two pairs of A's, you know all the other S's are proportional. So maybe it's something like 3 goes to 1, and maybe 4 goes to 4/3, and maybe 5 goes to 5/3. And what I did there was I took every side and I cut it down by 1/3. Okay? So if you know two A's, everything else falls in place and you have similar triangles. So this is the shape. This is the classic shape for the overlapping right triangle similarity. There are actually three triangles here, and I want to show you why the triangles are similar. Okay? Some of you might only see two triangles, so let me try and highlight to make it more visual for you. I have this triangle right here. I have this triangle here. So I have the yellow, the blue, and I'm going to over highlight all of it with the big green guy. So a yellow, a blue, and those together make the green guy. Okay, and what I'm going to tell you is if you pull them apart, just kind of separate it this way, those three are going to be similar. You don't know why yet, that's what I'm going to show in the next couple slides. But the green, the blue, and the yellow are going to be similar. One thing to note that will help you visually is this guy has a right angle, that guy had a right angle, and that guy had a right angle. So when we were talking about on the last slide that if you have two A's, then you have everything is similar. Well, right now I'm showing you that they all have a right angle. So if I can just show to you that there's one other angle in common, you have AA. So let me show you why the small and the big are similar. So the small guy again was here, and the big guy was the green one. And hopefully we are so far okay that when I pull them apart, they have the 90. They have the 90, so they have 1A. Now, here's the key. Notice where this guy came from and stare at the bottom left corner. And notice where this guy came from and stare at his bottom left corner. Both bottom left corners, here and here, are being shared right there. So you actually have two A's that are equal. And if you know that you have two A's that are equal, then the triangles are similar. Likewise, I'll show you why the medium and the big triangle are similar. I think you're already seeing the idea here. I have the blue and the big. And if I need to show that green is similar to blue, I'm going to peel them apart so you see it. We're looking for two angles. Right angle, right angle. Kind of connect it so you see it better. And then notice both of them stemmed from the bottom right. This angle here is being represented right there, and it's being represented right there in your triangle. So you had an A where they are being shared. It was the same angle. And you had an A because you knew they were right angles because it was given. So now the medium and the big triangle are similar. So why is the small and the medium similar? I am not going to try and do it the same way I did before because here's the issue. You have that and you have here. And right now, no angle is being shared by both of them. Notice there's no overlap here. It's a yellow, it's a blue, they are separate. But I want you to think through what we did on the last two slides. I just proved that small, that symbol there means similar. Small is similar to big. And I also proved that medium was similar to big. And this means if small is similar to big and medium is similar to big, you kind of connect it like a train, and you can piece it together and say small is also similar to medium. What that means is they have the 90, there's an A, they have this 90, oops, not there, they have this 90, so there's the A being 90, and even though it's not being overlapped, this angle here happens to be this angle here, and this angle here happens to be the same as that angle there. So if you have two A's, you know three A's, and you know all the sides are proportional. So now let's take a look at solving a problem involving these similar right triangles. And this one we are going to be solving via a proportion for the small and medium triangle. And the whole proportion that I'm going to set up, I'm previewing you it first and then I'll show it to you, is I'm going to do the long side over a long side equals a short side over a short side. When I set up this proportion, I am going to have the long side of the small over the long side of the medium is going to equal the short side of the small over the short side of the medium. So let me show you why I know this when I lay it out. A lot of times students get overwhelmed because they don't see all the sides, they don't see all the triangles. So the first thing I would recommend is drawing those triangles out. So let's scroll down here and draw those triangles out. So I have the small triangle, which has a 3 and an X. This is the small triangle. Okay. I have the medium triangle. That is X and 27, the right angle. And I have the large triangle, or the big, I guess I used the word big triangle, which is something like this. Notice how I orient them the same way. You actually know one thing about the big triangle. You know the hypotenuse is 30 because it's 3 plus 27. Now when you set up a proportion, you need 4 things. If you noticed up at the top of my proportion that I was going to use, I have a top left, bottom left, top right, bottom right. I need 4 numbers or 4 unknowns or a combination of those to solve. Well, the big guy only gives me one thing. It's the 30. So I can't really pair anything up there, but I can pair up with the small and the medium. Now the key is this. We need to identify who's long and who's short. So I'll highlight with the purple here. To me, visually, that's the long side of the small triangle, and it gets paired up with the long side of the medium triangle. And likewise, the short side of the small triangle should get paired up with the short side of the medium. So when I do this, I'm going to get X over 27 equals 3 over X. And I want you to see how this pairs up with what I mentioned above. I have the long side over the long side is equal to the short side over the short side. And it's a proportion because we already know the triangles are similar. Now you just need to solve that. Cross multiply and solve. So when you first cross multiply, you get 81 on the right side. It's not going to be 2x. It's actually going to be x squared. And you can square root it, and x equals 9. Okay, so that x, which is an unknown for the small, and it's an unknown for the medium, happens to be 9. And if you want to check your work to make sure that makes sense to you, let's take a look at that. If I know that this x is really 9, that means I have a triangle that's a 3 by 9, and I have a triangle that's a 9 by 27. And we had said that this long side gets paired up with that long side. Notice, that's a multiplying by 3. And then this short side gets paired up with this short side, and that's also a multiplying by 3, which again shows the sides are proportional. Let's look at one more. Here's one where the orientation of the 3 triangles is kind of rotated around. And so now you still want to see the small, you still want to see the medium, and you still want to see the big triangles. And to do that, again, I would try and draw them separately in a certain orientation. So I'll draw here. There's a right, the 2 and X. There's my small guy. I have the medium guy, which is here with a 16. And I have the large guy here with an X. And you do know again that the hypotenuse adds up to 18. So this was the medium, and this was the big. So now you got to find your pairings. I see the small, I see the big pair up, and I'm going to try and do this. I'm going to do hypotenuse over hypotenuse equals side over side. Hypotenuse over hypotenuse equals side over side. Cross multiply, and you get x is 6. So hopefully this helps lay out proportions in similar right triangles.